In this tutorial, we're going to discuss complex numbers, whereby we are going to look at how do we define complex numbers, how do we add complex numbers, different arithmetic operations of complex numbers. We're going to work them out in this particular video. We shall also look at what we mean by conjugate and where do we use it, especially in division. And then we shall also have the full discussion on numbers in evolving, how we are going to work out different forms of complex numbers. So to begin with, we are going to define what we mean by a complex number. So we can say that a complex number has the form a plus bi. So we need to appreciate the fact that complex numbers is an extension of real numbers, meaning there is some situation whereby you are working out question to do with real numbers and then you were unable to find the solution. For instance, when you are finding the square root of negative numbers, so that's where now complex number comes in. Now in this complex number that we have at this particular point, this is known as the real part of this complex number, and this part that we have here is regarded as the imaginary part. This is the imaginary part of these complex numbers. So a complex number involves the real part and the imaginary part. So the next part that we're going to look at is addition. How do we add addition of complex numbers? If you are given complex numbers, how do you add them? Now, this is exactly what we are going to look at, addition of complex numbers. And we're going to have a classic example here, which is going to enable us try to work out this. For instance, we are given 2 plus, we are given 2 plus 3i, and you are adding this to 3 minus 4i. So in order to add these questions, you need to look at the real part and the imaginary part. So for instance, if you look at the real part here is 2, the real part for this second complex number is 3. So which will mean that whenever we are going to add this, we are going to say that this is going to be 2 plus 3, then plus. We shall add the imaginary parts. The imaginary part is 3 and negative 4. So this is going to be 3 plus negative 4i. So if we work out this, we are going to realize that the answer is going to become what? The answer is going to become 5 minus I, because 3 plus negative 4 is going to give us negative 1, and now this becomes our final answer in that case. If you are given question to do with subtraction of complex numbers, you are going to use the same and follow the same approach, because if you are told that z is equals to 4 plus 3i, this is our z1, and you are given z2 is equivalent to negative 1 minus 5i. So which means that if you are told to find z2 minus z1, in order to work out this, we are going to say this is going to be equivalent to what? Let me just use a marker that is a bit visible at the other end. So we're going to say this is going to be Z2. Our Z2 is minus 1 minus 5i minus Z1. Our Z1 is this one, which is 4 plus 3i. So we are going to subtract the imaginary parts and we're going to subtract the real parts. So I can just decide and open this bracket here and say this is minus 1 minus 5i. Then this becomes 4 minus 3i. Because of that, I'll put the imaginary part and the real parts together, and that is going to be minus 1 minus 4 plus minus 5 minus 3i, and that is going to be, if I work it out, I'm going to get negative 5, then minus 8i as our final answer. So that's what we are going to do as far as addition and subtraction is concerned, uh, complex numbers. Now, the next area we're going to look at is actually multiplication of complex numbers. How do you do multiplication? How do you multiply complex numbers? Multiplication, use small letters. Multiplication of complex numbers. So we shall start by looking at some symbol examples. Here, the first one that I want us to use is number 1. I want us to work out 2 over 3 minus 6i. So if you are given a number like this and you're supposed to multiply this, it means this is a constant multiplied to the two parts of a complex number. So we have the real part and the imaginary part. So this is going to mean this is going to be 2 times 3, which is going to be 6, 2 times minus 6i, which is going to be minus 12i. Now this is the answer for this. But in the event you have 3i multiplied by negative, let me use negative 7 plus 2i. So we're going to say this is 3i times negative 7, then plus the answer we are going to get, we add to 3i, just 3i times 2i. So if we multiply 3i times negative 7, that's going to give us negative 21i. But if we multiply 3i times 2i, we need to remember that I times I is actually negative 1. Is negative 1. So meaning that this is going to become negative 6 as the final answer. And this we can be able to write this and say this is negative 6 minus 21i. So it means that once you are having an imaginary number multiplied to another imaginary number, you are going to get a real number. So once we have worked that out, I want us to change the gear and try to look at another question whereby we are supposed to do the multiplication. And here we have 3 plus 2i times 1 minus negative 1 plus 4i. So we need to work a third example here. 3, this is actually 3 plus 2i is multiplied to minus 1 plus 4i. So in that kind of a scenario, how do we approach this? Because we can be able to say this can be expressed to multiply this first term with the everything that is in this second bracket, and that's going to be what? 3 into bracket minus 1 plus 4i, then plus 2i, which is multiplied to everything that is in the second bracket minus 1 plus 4i. So, which will mean that if we work out this, it will be minus 3 plus 12i, then 2i times negative 1 is going to be minus 2i, 2i times 4i, that's going to be 2 times 4 is going to give us 8, but I times I is going to give us negative 1. So we are going to have negative 8 as the final answer in that particular part. So we can now put the real part and the imaginary part together. And this, now we have the real part, negative 3 minus 8. Then we have 12i minus 2i. So which will mean that this becomes negative 11, and then if we subtract this becomes 10i. So upon multiplying these kind of questions, we are going to get this value. So it's just the normal understanding of opening brackets, the way we used to do in algebra. But also you need to take into consideration that I times I is actually negative 1. So that's why we are saying that if you are finding a square root of a negative 1, the answer is I. So, and that's the beauty of the introduction of complex numbers, so that whenever maybe you get a situation whereby you are finding the square root of a negative number, you will be able to proceed to the next part. But when we were doing normal math in O levels, the moment we could reach at this point, we could say that this has no solution. But now we can now see that due to the introduction of this extension of real numbers to complex numbers, we are able to proceed from there. All right. So we can also look at another situation whereby we are doing multiplication. And this is the part that I'm going to introduce, because we're going to learn about conjugates. And conjugates, when you multiply a complex number and its conjugate, you are going to get a real number. So before we go into that, let me just give you a scenario for whatever I'm talking about. So under the third example of multiplication, the fourth example, number 4, we are given 2 plus 3i, and you are expected to multiply that to 2 minus 3i. So you can see the only difference that these two numbers have is that one, the imaginary part of the other, has the opposite sign. So let us just look at it in terms of the normal multiplication. We are going to say this is 2 going to be multiplied to everything that is here, 2 minus 3i, then plus, because we have the positive sign there, we're going to say plus 3i multiplied to everything that is in the second bracket, and that is 2 minus 3i. So if we multiply this, we are going to get here, this is actually 4, and this is going to be negative 6i, this is going to be plus 6i, and the other one is going to be 3 times negative 3 is going to give us negative 9, and but negative I times I is going to give us 3 times negative 3 is going to give us negative 9, but I times I is going to give us negative 1. So that is why at the end we are going to have positive 9 in this case. But now you realize that this part 2 will cancel out, because 6 minus 6i plus 6i is going to become actually 0, and then we're gonna end up having 4 plus 9, and the final answer is going to be 13. So we have a real part. When a number, a complex number, is multiplied to its conjugate, we are going to get a real number. So we are going to look at conjugate of complex numbers. Conjugate of complex numbers. How can we define a conjugate of a complex number? How can we define it? We're going to say a conjugate of a complex number is another complex number. A conjugate, a conjugate, a conjugate, a complex of a complex number is another complex number. Is another complex number. And this complex number that we are talking about which has, we can say, which has same real part but opposite sign in the imaginary part. So that is a simple definition of what I mean by a complex number. So a complex number has, every complex number has got a conjugate, and the conjugate and the complex number that we're talking about differ only the sign of the imaginary part. So in that way, for instance, if we're saying Z is a complex number, which is A plus BI, so the conjugate is denoted by this symbol, and that's going to be A minus BI. The only thing that they are different in this is the sign that we have there. So we can say an example, we have Z equals to 3 plus 6i. Its conjugate is going to be 3 minus 6i. If you are having Z is equals to minus 5 plus 2i, its conjugate is going to be minus 5 minus 2i. If you are having Z is a complex number whereby it's negative 1 minus 3i, then its conjugate is going to be minus 1 plus 3i. So they only differ in terms of the sign of the imaginary part. So given any complex number, and then you are supposed to convert it to, you need to write its conjugate. What you need to change is the sign of the imaginary part of that complex number. Now we need to move to division, and we shall see how do we use this conjugate. So we say division of complex numbers. So you may be given questions whereby you are supposed to divide two complex numbers. So we can say, let's look at an example at this given point. We are saying that given Z is equals to 3 minus 4i, this Z1, and Z2 is equals to 2 plus 5i. And you are supposed to work out we are supposed to work out 2z1 over z2. We are supposed to work out 2z1 over z2. So the first thing that we need to look at here is what is actually, how can we be able to write this? So if we are working out this, the first thing I will have done here, I will have said this is 2, but then my z1 is actually 3 minus 4i, yeah, then divide by z2, which is 2 plus 5i. So first I will have simplified that before start thinking of exactly what next to do. So this is going to be 6, then this is minus 8i over 2 plus 5i. So once we have this, then I'll go ahead now think about the conjugate. And the conjugate we're going to look at is the conjugate of the denominator. And this is going to be times 2 minus 5i. And also we multiply to the numerator the same 2 minus 5i. So once we have this, I'm going to multiply this together and this one together. Then we're going to say that this is going to translate to, can I make use of this space? Oh, okay, let me just write here. So this is going to be 6 times everything that we have in the second bracket, and this is going to be 2 minus 5i, then minus 8i multiplied to everything that we have in the second bracket, that is like that. And I'm going to multiply that to 2, the 2 I'm having here, times everything that is in the second bracket here. So that is going to be what? 2 minus 5i. And this 5 that I have here, that is plus because of this addition sign at this point, plus 5i multiplied to 2 minus 5i in that case. So we are going to open the bracket wherever we could and whenever we can. And this is going to be actually 6 times 2 is going to give me 12, minus 6 times negative 5i is going to give me negative 30i. And then this is going to be minus, because negative 8 times 2 is going to give me negative 16i. And I have negative times a negative, it will be a positive, but I have I times I, which is going to be negative 1, and meaning that now the final answer here is going to be minus 40 in that case. Then we have here 4 minus 10i. This is 5i times 2 is going to be positive 10i at this given point. And now I have 5 times negative 5, it will be negative 25, but I times I is going to give me negative 1. So I'm going to have positive 25. This point, I will have positive 25 here. So now I need to simplify and put the real and the imaginary part together so that we can be able to get our final answer in this case. This is going to be actually 12 minus 40, and this is going to be minus 30 minus 16, minus 30 minus 16, that translates to minus 46i over this part. 10 minus 10 plus 10 will cancel out, and I'm going to have 4 plus 25. So 12 minus 40 is going to give us negative 28, and this is minus 46i, and this other part that we have here is going to give us 29. So if we are working out this and give our answer in the form a plus bi, if this is the form that we need, then it means that you are almost home and dry, because you are going to say now this is the same as negative 28 over 29 minus 46 over 29 I as our final answer. That's the symbol steps you are going to follow in order for you to divide complex numbers. So the next area that we're going to look at, how do you convert complex numbers from different forms to other forms? For instance, how do you convert a complex number from a Cartesian form to a modulus argument form? How do you convert a complex number from a Cartesian form to an exponential form? And then we're going to see the advantages of having those forms. Where are they going to help us in the process of working with complex numbers?